On this question, we want to use the properties of logarithms and the logarithmic property of equality to solve the logarithmic equation. The equation that we're working with is log base 3 of x plus 6 minus log base 3 of x plus 2 equals log base 3 of x. So we want to use the property of equality, or the one-to-one property of logarithms. Different sources name this property differently. This book that we're working with uses the property of equality. And what this property of equality says is that if you have the log base b and on the other side of the equation log base b, so I have the same log, same base on both sides, then this property says that what's inside the log on the left has to equal what's inside the log on the right. So it allows us to remove the logs from the equation, creating a much simpler equation to solve. So we really want to be able to use this property here. When we look at the equation that we have, here's our equal sign. And on the right-hand side of the equal sign, I do have a log with base 3, so it looks very similar to the right-hand side of our property. However, the left-hand side of our equal sign doesn't have just a single log, it has multiple logs being subtracted in this case. It is good that we see log base 3 on all of them, which matches the log base 3 on the right. So eventually we will be able to use that property of equality because all of the logs have the same base. So we need to resolve having multiple logs on the left-hand side here. And that's where it comes into play, these properties that I have down on the bottom here. These are log properties that we can use for either expanding or condensing. And in this case, we want to condense. We have multiple logs, and we want to condense them into a single log. So you'll notice here I have subtraction in between the logs. And so I'm going to go down to the property that we're going to use that has subtraction right here. So when we have subtraction of two logs, we're going to be able to condense them to a single log using division inside of the log. So that's called the quotient rule for logarithms. And so the way we're going to write the left-hand side, both of them have base 3. So we're going to write one log with base 3. And inside that log, I'm going to do division because we have subtraction of two logs. In the numerator, we use the log that is positive, x plus 6. And in the denominator, we use the log that is negative, the x plus 2. And you don't use the whole log, you just use what's inside the log. So our left-hand side can be condensed using the quotient rule to log base 3 of x plus 6 over x plus 2. And the right-hand side, we didn't need to do any condensing to. So we have used that quotient rule to condense. And now we have a log of base 3 on the left and a log of base 3 on the right. And we can apply that property of equality and say that what's inside the log on the left has to be equal to what's inside the log on the right. So x plus 6 over x plus 2 is equal to x. So it allows us to get rid of those logs in the equation. And now we have an equation that we're more familiar with that doesn't have logs. So I'm going to transfer it over to the right-hand side here. We have x plus 6 over x plus 2 equals x. We're going to solve this by multiplying both sides by the denominator. So I'll multiply the left by x plus 2, and I'll multiply the right by x plus 2. That's going to clear the fractions or cancel the denominator, leaving me with x plus 6 on the left. And on the right, I can use the distributive property to get x squared plus 2x. And now that I've gotten rid of that denominator, I can see that I have a quadratic equation that's got this squared here. That's how I know it's quadratic. I'm going to move all the terms to the same side and see if I can factor. So I'll subtract x and subtract 6. That gives 0 equals x squared plus x minus 6. I can factor to get x times x is x squared. 2 times 3 is 6. And I'll do a plus on the 3 and the minus on the 2. I'll set each of these factors equal to 0. X minus 2 is 0. X plus 3 is 0. And that gives x equals 2 and x equals negative 3. So we do have some values for x, but we're not done solving this question yet because log expressions have domains that are restricted. And what that means is that you're not allowed to plug just any number into logarithms. When you have a log, for instance, log base 3 of x, you're only allowed to substitute x's that are positive. Log of 0 is undefined and log of a negative is undefined. So anytime you solve an equation that involves logarithms, once you get your values of x, you need to check to make sure your values of x are in the domain of the original equation. So I'm going to start by checking x equals 2. So x equals 2 gives log base 3 of 2 plus 6 minus log base 3 of 2 plus 2 and log base 3 of 2. And what you're going to check is inside each log you should have a positive value. 2 plus 6 is a positive 8, 2 plus 2 is a positive 4, and 2 is positive. And so we're going to be able to keep the solution of x equals 2 because it's in the domain of every log expression. We'll do the same thing for x equals negative 3. So we're going to check x equals negative 3, and that gives log base 3, negative 3 plus 6, minus log base 3 of negative 3 plus 2, equals log base 3 of negative 3. So I'm checking each expression inside the log. The first one, negative 3 plus 6, is a positive 3. Negative 3 plus 2 would give you a negative 1. So that expression would be undefined if we substituted a negative 3 in, and as well as this one here. And so that means that negative 3 cannot be a solution to this log equation, and we're going to exclude it. So the only solution to this log equation is x equals 2. Thank you for checking out my videos. Have a great day.